Hey, physics peeps, Mr. McLeod here. So what I'm going to do for you today, on this video, is I'm going to try to show you how to do some of the things in Sheets that we'll need. I'm going to start with just a made-up graph. I actually went back and I took the last 10 days of temperature. I just went to a random weather website that tells us the past. I'm going to put this in F because this is temperature in Fahrenheit. Doesn't really matter. This is just a label. This is just so I can see things. Now, when you're doing your graphs, make sure you label your graphs like this. Put like a title, maybe bold it, maybe even underline it. So that way I can tell where your title starts and your numbers begin. And we will be combining our data together in Sheets. So I don't want one person that just throws numbers all over the place and another person who has them organized, because when we try to put them together, it's going to get very messy and take a lot of work. It's easier if everyone kind of just goes title, numbers, title, numbers, title, numbers, title, numbers. So what I'm going to do is I'm going to try to create a graph where I have days in the x-axis and I have the temperature in the y-axis. And I want to see how temperature changes day to day. And a lot of times we do this sort of thing where we compare an x and a y-axis to kind of see if there's some sort of function there, to see if maybe there's a pattern, to see something like that. We're probably not going to see too much of a pattern because it's just the weather day to day, but I just want you to see how to do it. So the first thing I'm going to do is I'm going to type in the days. I'm going to go 1, 2, 3, 4. Already you can see this is going to take me, it's going to take me a few seconds. But what if I instead had 1,000 days and 1,000 temperatures, and I was looking at overall temperature change over years or decades? I would not be able to sit here and type out all these numbers. And so instead, what we would want to do is we'd want to use a formula to do it for us. So I have the number 1 here, and usually when it comes to making up a formula, you just got to think your way through the problem a little bit and say, I could do this with a formula, I'm going to do this. So we have 1 here. But what do we want this one to say? We want this one to say 2, and we want this one to say 3, and this one to say 4, and so on and so forth. So to do that, we need to add 1 to the first one for this one. So to do an equation, to make that happen, is you want to start with the equal sign. The equal sign tells Sheets, and this works in Excel as well, it tells it that you're about to start an equation that it's going to use. It's programming. If you didn't have the equal sign and you just started typing in programming code, it wouldn't recognize it. It would literally just put whatever you typed here into the box. It wouldn't actually do any calculations. So equals is what we want to start with. Okay, so what do we want to do? We want to take this number and add 1 to it. So I'm going to click on this number. Okay, and I'm going to go plus 1. And if you notice when I clicked on this number, it actually added the cell B2 in yellow. I could have typed this in, but it's a lot easier just to click it. So equals B2 plus 1. By the way, this also works if you have multiple tabs. You could take information from another tab and add it into yours using the same method. You would hit equals, and then you go and click on the tab you want, click on the cell you want, and it would add it right in there. But it would be a little longer. It'd say like tab whatever B2. But anyway, I don't want to complicate things too much. So B2 plus 1, I'll hit enter, and sure enough, it says 2. Okay, to see if this works, let's say instead of starting on day 1, we started on day 5. What should this become? This should become a 6. Good, it's working. The code works. Okay, then I could type in equals B3 plus 1 equals B4 plus 1 equals B5 plus 1. Or to make it faster, I can click this little corner spot, drag this, and what it's going to do is it's going to copy and paste that code for every single box I copied it into. Okay, now I could do it that way. Another way you can do it, and I do this in Excel usually, is I'll go Control C to copy, I'll hold Shift and select all the other boxes, and then I'll hit Control V to do the same thing. But as you see, the formula just changes by what cell came before. So it's pretty smart. If I just did that with a number, let's say I had 65 here, and I clicked here and drug this down, it would literally just copy the same number over. It copies whatever's in this cell over and over again. But like I said, the code makes it smarter. Okay, cool. So we have a temperature and we have a day. This code's pretty simple. We're in physics, so I don't want to be in Fahrenheit. That's one thing I want to change. So what I'm going to do is I'm going to go over here and I'm going to create a new column, temperature C. Okay, temperature, and that's going to be in Celsius, right? Not going to worry about Kelvin in this class too much. It's more of a AP2 or a chemistry thing. Okay, temperature in Celsius. So what is the formula for temperature in Celsius? Well, I don't have it memorized, but fortunately, I looked at it a few minutes ago and I kind of have it in my head. You take the temperature it is in Fahrenheit, you subtract 32 from it, and then you multiply that value by 5/9. So what I'm going to do is brackets are important, so you're going to do the same thing you would do with math, is the order of operations is super important in programming. So equals, I put in parentheses, this number minus 32. I'm going to close the parentheses, so this will give me a value. 84 minus 30 actually tells me what it is. It says up here, hey, it's going to be 52, by the way. But now I need to multiply it by, I'm going to do another set of parentheses, 5/9. And we get, you can kind of see what we're going to get, but I'll hit enter so you can see it. 28.88888889 degrees Celsius. I could cut that off by, you see, I believe, no, that changes the decimal, doesn't it? Nope, it doesn't. So I hit this over. I only want to get maybe 1 decimal. That's probably good because we're not going to get, well, really it should be this, right? Because none of these have decimals, we shouldn't be getting answers in decimals. So this is 28.9. I don't like this because it's not auto rounding. We'll leave it right there. It's not perfect, but it works. All right, so 28.9 Celsius is equal to 84 degrees Fahrenheit. I believe that. That sounds about right. Once again, I'm just going to copy and paste this all the way down. And boom. There we go. We now have all the temperatures in Celsius instead of Fahrenheit. And I didn't have to do a whole lot. It was pretty simple, right? I'm going to center this because it looks better to me. And I'm going to bold, Control B, Control U to bold and underline. And there we go. Cool. Now, what's kind of interesting is, let's say I change the number over here on accident. Let's say I set this to 90. It's going to, when I hit enter, it's going to change this number over here. Okay, let's undo that. And you'll see that it goes back to what it was. So this is actually now a system, right? And let's say we did another set of math on this. We did another column over here that said, let's add 5 degrees to each one of these. If we change the first one, it would change this one, which would then change that one. So it becomes sort of like an engine. Changing one system, one part of our columns, is going to change all of them, which can be very useful. You could do this, you could do it on purpose, but it could also cause a lot of mistakes if you do it on accident. Another thing, just so you know, if I copied all of this, Control C, over here, Control V, it automatically, inside of here, adjusted. If you look at this one, it says A2 is where it's drawing that number from to calculate temperature. This one automatically now knows to do G2. So it goes the same number of spaces over. It knows to fix that. This can cause problems. Like if I just copied this right here and moved it over, let's do that real fast, and it didn't have something to draw from, so Control C, and I moved it right here, Control V, it set it automatically to 0 because there's nothing in E2. There's nothing there, and so this is all calculated incorrectly. If you ever want to just get the numbers, which is something that commonly happens, you go copy, but when you go over here, you'd right-click, paste special, paste values only. So now these numbers are separate. You can do things with them, and you're not going to affect any of the formulas. And actually, if I change these numbers now, 22, it changes here, but you look, it does not change them here. So that is one way to keep, if you have to make multiple copies of something, that saves it. All right, so I'm going to get rid of this column. It's kind of redundant, and you'll see why. It kind of helps in a moment. All right, so now I have these two. I'm not going to use this one at all. I could hide it technically. I think there's a hide function somewhere, but I'm going to leave it there. I'm going to use these two. I'm going to have this be my x-axis and this be my y-axis. All right, so let's go insert. Where is it? Chart. Now I could have done right-click chart as well. There's 2 ways of doing that. We're never going to do a column chart or a pie chart or an area chart. It's always going to be a scatter chart. A scatter chart is literally just dots representing points. So there's going to be a point at 1, 28.9. There's going to be a dot at, and then we can actually interpret that however we want. These other things, they kind of they don't fit anything with measurements. They might be good for functions and stuff. All right, so x-axis. Okay, what's my x-axis going to be? I click on it. It says select data range. I could type numbers in here, or I can just click over here and select all of this. Remember, we always want time in the x-axis because time never goes backwards. And if you guys remember the rules in algebra, you also never go negative. You never go backwards on the x-axis in a function. Like you never curl back up on yourself, or it's not technically a function. It's one of the rules that makes something a function, right? That's one reason we put time in the x-axis. All right, so that's the x-axis. Okay, nothing's appeared here yet, and that's because we don't have a y-axis. So I'm going to click on series now, and I'm going to click on, you see this little symbol, select the data range. Click that, and then I'm going to select all the temperatures. Series is the same thing as y-axis. It does not work this way in Excel. If you go to Excel and you click Add, and then you click Edit, it'll actually give you a specific. It'll say X, Y. It'll give you name X, Y. You can name the line that you're making, and then you can choose your X and Y. This uses data range. Okay, so click OK, and sure enough, look at that. We have day 1, day 2. Now, by the way, day 1 is 10 days ago, so that would have been on a Friday. You're gonna see temperature went up, came down, came down. Now, what might be interesting, no, this doesn't seem very useful. It's not really a pattern. You can kind of see that it goes up and down in little waves. If you looked over a longer period of time, what might be a connection here, though, which you don't have to dig into, I'm just thinking about this as a scientist, is, well, maybe these temperatures started to drop as soon as the smoke started to hit the Tri-Cities. So maybe there is a pattern here. Maybe there is a direct relationship between smoke in the air and the amount of sunlight that reaches us, and that's why we see a sudden drop in temperatures. You see drops in temperatures for volcanic eruptions and stuff too, because aerosols and particles in the atmosphere block sunlight for a while. It's not a long-term solution for like climate change or anything, but it does cause a temporary cooling effect. You would think volcanoes would cause a heating effect, but they actually cause a cooling effect because they blanket the earth in ash and dust. Anyway, so this is how you make a graph. If you want to label the graph, which you will want to label the graph sometimes, I right-clicked on here, chart area, chart style, chart axes, and titles. Chart title, if I click that, that'll let me add a tile on the very top, whatever you want to call it. Horizontal axis, that's the x-axis, so I might do that and type in the word days. So it even gives you the options for what font and everything else. Minimum and maximum value, I can actually set this, if I set this to 4, the graph would actually start here instead of here. All this would disappear. Sometimes there are graphs, like, do we need anything at 10 here? Probably not. So what I'm going to do is I'm going to go to vertical axis, and you see where we have it's not letting me, oh, there we go, show minimum value. Minimum instead of 0, I'm going to set it to 10, and what you'll see is now 10 is the minimum. And really, we could even gone to 15, right? Because we don't have any numbers below 15. And there we go. That kind of zooms in on the data a little bit. Another thing we can do, I believe you can do down here, is you can click on one of the dots, and I believe we can connect the dots, which is useful when you're trying to, where would that be? There's error bars, so we don't want to do error bars right now. This is a little difficult because in Excel you can actually put in what's called a trend line that will actually tell you if there's a formula that matches this curve, and you can try to recreate the formula, and then that helps you sometimes go back and say, oh, what's the physics going on? You don't normally use sheets for science, but for what we're doing this level, it's fine. You usually use Excel for basic level algorithms, and then something more complex like Mathematica, which is like a math programming language for more advanced work. And I've been using it quite a bit recently for what's called a regression coefficients. And I'll tell you guys about what that means later. But basically, it's really fancy ways of finding the error bars and uncertainties in my calculations and other people's calculations, really. Anyway, so that's it. That's how you do that. That's how you make a chart. If you ever want to add another bottom here, you just click a plus sign. That will add more things here. I told you guys in the instructions you have to rename it your name. By the way, this is the instructions. I literally say do not accidentally erase other people's tabs. We're going to be sharing this file, so if somebody messes with it, everyone gets messed with, and we don't want that. This is where all your combined data is going to go, is where you're going to put your circumference, your diameter, and your calculated value for pi. Okay, what I mean by calculated value for pi is you take the formula that circumference equals 2r, which is 2r pi or 2 pi r, which is really just saying diameter times pi. And to create calculated pi, you literally could just go circumference divided by diameter, right? You just rearrange the circumference formula, and you should get pi. Now, I don't want you to get actually pi, because you are measuring these things by hand. I want you to get as close as you can. And that's probably not going to be super close, but that's fine. That's why I'm combining all of our data from all of our classes and all of our things. So when we're done, then we'll actually get close to pi, which is actually how pi is calculated. If you guys didn't know, pi is literally just the ratio of circumference to diameter. That's where it comes from. And the ratio of circumference to diameter is always pi. And if you remember, a ratio, it just means a number over a number. That's the same thing as a y over an x, right? A rise over a run. So the slope of a circumference versus diameter graph, well, you could probably guess what that slope should be, right? Think about it. I'm not going to give you all the answers on this one. I want you to think through some of it. I want you to fight through some of it, because that process is going to help you learn how to do some of the physics, because later on you're going to be doing things that are a bit more complicated with things like friction and springs and momentum and energy and stuff like that. And I want you to make these discoveries as we go the best that we can, because if you're just trying to memorize formulas and memorize stuff, you cannot do very well on the AP exam that way. You kind of have to have a general understanding of how things work to then place math as a second thing. So anyway, that's what this activity is for. Anyways, I've rambled on long enough. I'll let you guys go. And yeah, so here's your instructions for using sheets. And of course, a little bit into the lab as well.